Hi, welcome to Kids in Chemistry. Today we're going to talk about three concepts: refraction, reflection, and index of refraction. And we are going to look at three science experiments that are kind of like magic tricks that demonstrate each of these concepts. So stay tuned. The first thing we're going to talk about is refraction. So I have a regular glass here, and I have printed out a picture of two fish. And I just want to show you, first of all, that there's nothing strange about this glass. You can see it distorts the image a little bit, but the fish is still facing this way, right? Here's the head, it's facing that way. Now what I'm going to do is I'm going to pour water in the glass. And what happens is it actually changes the direction that the fish is facing. Oh, now it's facing over here. Kind of like a magic trick. What's happening is the light is refracting or bending as it goes through the glass, and it's changing the direction our fish is facing. The next topic we're going to talk about is reflection. Reflection is basically when light bounces back. So you know this when you look in a mirror, you see your reflection, right? So we're going to use our same plain glass. I'm going to put a white piece of paper under just so we can see a little better. And what I'm going to do is I'm going to take a coin and I'm going to put it underneath the glass. Right now you can see the coin because the bottom of the glass is transparent. But what happens when I put water in it is that the water in the glass has a different index of refraction. So it's actually making light refract so much that it's reflecting, and it's turning the bottom of this glass into a mirror so we can't see what's underneath it anymore. You can see that the coin's still there, but when I have the cup of water on it, I can't see it anymore. Kind of like another magic trick. The final concept we're going to talk about is index of refraction. All materials have an index of refraction, and it's basically just a number that indicates how fast light travels through that material. For instance, air has an index of refraction of close to 1 because light travels very easily through air. Water, on the other hand, has an index of refraction of 1.333 because light travels a little slower through water than it does through air. So why is this important? When materials have different indices of refraction, that's when light refracts when it goes through those interfaces. So for example, this glass is transparent. How can I see it? The reason I can see it is because light's actually bending as it goes through here because it's going from air to glass, which has a different index of refraction. So it's refracting the light and I can see this. We're going to do another magic trick where we look at two materials who have the same index of refraction. So in here I have vegetable oil, which has an index of refraction of 1.47. And I also have this test tube, which is made of borosilicate glass, which should have the same index of refraction as vegetable oil. When I start to put it in here, you can see it because there's air inside. What's going to happen as soon as this is completely surrounded by vegetable oil is it pretty much disappears. If I can get it full of vegetable oil, because it has the same index of refraction, so the light is not bending when it goes through the through the vegetable oil, through the glass, and then through the vegetable oil again. So it pretty much disappears. That's it for our science experiment magic tricks today. Thanks for joining me.